This here is the next thing we want to have a look at. This is how it looks like. Hello and welcome to our lesson of Rotary Encoder. What is this Rotary Encoder? It has a turning knob. We can turn this, yeah, and we can turn it through. It has no limit. Yeah. We can also turn it on the other side. It has also no limit. And then there is also click, 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 a button. Yeah. How this is working? We do see we have some connectors. It's count CLK. Then there is DT, SV, SW, plus and ground. Plus and ground is clear. This is the power supply. SW means switch. DT and CLK are two contacts. How they are connected, I will show you. And in the meantime, please, original Heinz, build up the hardware. Of course, real Heinz, of course. I will start immediately, okay? No problem. So, we're talking about this rotary controller. Oh, rotary encoder. Basically, the rotary encoder looks like a gear. I'm not sure if I got the right amount of teeth, but we will be fine. Okay, one of the things, so this is a conductant material, so this is latent, yeah, conducting. Okay, this one is connected to ground. Okay, so this is G and D, it's connected here. Okay. Then we do have two connections, yeah, which are very close to each other. There's the connection A, call it A, and there is the connection B. And both are connected by a pull-up resistor to plus 5 volt. Okay. This is how this looks like. This is all built in our device here. Okay, the switch is, I will not draw it, it's just connecting. Yeah, it's just connecting the SW pin. It's just connecting the SW pin to ground. Okay, not really sophisticated, but let's see what is happening here. Yeah, let's see what is happening here. I will draw both signals. Draw both signals. Here we have got signal A, and here we have got signal B. Okay, and they are changing between plus 5 volt, that's here, and 0 volt or ground. Okay, in this position. Both are connected to ground. Okay, both are connected to ground, and so both are at 0. A is 0 and B is 0. Now I'm starting to turn my knob here clockwise. Then I end up in a situation where it looks like this. I just turn it a little further. Okay, suddenly A is not longer connected to ground, and A will be pulled up by this pull up to plus 5 volt. Okay. B, nothing is happening because B is still connected. Okay. Then again I turn it a little further. Okay. So I turn it to exactly the opposite like it was before. Next position. And here you see both have already left the tooth. Okay. So this means A will stay up, yeah, and B will also come up to 5 volts. Okay. Now again I turn it a little further, yeah, and I end up in a situation like this. Now it's really getting very übersichtlich. Everybody but what hopefully you can still see here, even if I manage to make a lot of dots. Now A is already touching the next tooth. Tooth was coming up and is already connected to A. Yeah? So this means A is going down again and B is not yet connected. Yeah, it's still not grabbing, so B will stay up and A is going down. And then we are exactly one tooth further. Yeah? We're exactly in the same position because we cannot distinguish the teeth. This means A stays on ground and B goes to ground. This is what's happening. Okay? Real lines? Original lines, yes? Sorry for interrupting.
Okay.
I just heard what you said, and I just wanted to mention I have exactly a thing which could show exactly this behavior. So if may I allowed to briefly interrupt you? Yeah, please, Heinz, do. Okay, thank you very much. So let's see what I've built here. Plus and minus. Yeah, plus and minus to the encoder, and this green and yellow line, they are the contacts A and B, which was just mentioned by the relines. Okay, so and now I could just plugged in two LEDs, the red one and the blue one, to those two contents. And if I'm turning, I try to turn now very slow, then you will see, one is off, a little bit further, second is off, a little bit further. Okay, this was not perfect. Let's try it once more. So slowly turn further. Red is off. Then blue is off. Then red is on and blue is on. You see, that's exactly the behavior. It's not that easy to turn that little knob that slow, because if you turn it a little bit, then you see it's blinking. Yeah, and there's also rasten. Yeah, it's settling. Tock 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 tock. It's moving in steps, so it's not that easy to move to make it that slow. But you see, it's exactly working like real hand said. Yeah. So I will now connect those two inputs, and real hands, please explain further. Okay. Sorry for interrupting. So you see, it's really like I told you. Yeah. Even in original Heinz hardware setup. So, and this is nothing. If we turn it further, this will happen all the time. Okay. What is it good for? I mean, if I just want to know how far I've turned, because this is what this thing is originally, the intention of this thing is, I just have to count how many ticks on A I've got. Yeah? However, if I only have one connection, I cannot distinguish if I'm turning clockwise or counterclockwise. Yeah? This is clockwise. Counterclockwise is exactly the other way around. Yeah? So, how can this be distinguished? Let's say A is coming to top. Yeah? Then I just have to look on input B. If input B is low, I know I'm turning clockwise. Okay, let's have a look on the other edge. If I'm turning counterclockwise, I'm exactly at this point in time where A is coming high, I'm looking at B. B is also high, so B high means counterclockwise. Okay, suddenly every time I have here rising edge on A, I just have to look at the other channel, yeah, and tell if it's counterclockwise or clockwise. Counterclockwise or clockwise. Yeah. Suddenly I can distinguish if I'm turning left and right. And now I have a device which I can turn lower and higher, yeah, with an unlimited movement range. Just have to count. And I even have a button that I can confirm whatever I adjusted. Fetzen. Shoot, fetz. Okay, it's not for fetzen. It's not for shooting, of course. It's an input device. Okay. So, original Heinz, how far are we? Yes, I'm ready. So, you can go on with the coding. Perfect. Okay, so this is what Heinz was building up. Yeah, this is the hardware setup. You see, plus and minus. Right now, I mean the breadboard is not really useful here. We could directly connect here, but anyway, it's in. Yeah. You see, the switch pin is connected to pin number 4, pin A is connected to pin number 2, and pin B is connected to pin number 3 of our Arduino. Okay. And what we are going to program, yeah, if we just have a look on my drawing again, we want to look if A is changing, yeah, and have a look on the B side. If the B is equal to A, then we have a counterclockwise rotation. If B is different to A, then we have a clockwise rotation. And this is also true if we, let's say, we come in here, dropping, yeah, here B is the same, yeah. This means also on the edge, on the falling edge of A, we can distinguish if we are turning counterclockwise or not. Because if we are coming from this side and we're falling, then B is different than A. Every time B is different, every time A is changing something and B is different than A, we're turning clockwise. Every time A is changing something, rising or falling, and B is the same like A, we're turning counterclockwise. This is what we try to code. Okay. So let's see. Saved, yes, I have already saved it, so I will define my pins. So pin A, this was pin number 2. Pin B, this was pin number 3. And finally we have button pin, this is pin number 4. Okay. Pin modes, the pin modes I will also do a serial dot begin. I want to send me some messages. I like to talk to myself. It's great to talk. If nobody else is doing, I have to do it. Sad. Oh, so sad. Don't worry. Pin A needs to be an input. Remember, the pull-up resistors, they are already built in there. Pin B is also an input. And finally, pin button. This one I have to define as input pull-up because it's not with an internal input. Yeah? And I will write myself a message, serial.println, reading from encoder. Nice. Yeah. Now, I already read something from pin A. I make a digital read, and from this pin A button. And of course, I have to know what was in my previous thing, and I will do it now this time with an last pin A, with a global variable, because I'm reading here last pin A already the first time in my setup. So if I wake up, I'm already reading the digital pin A. Okay. Then at some point in time later I'm here, and here I only have to compare. Yeah. So if pin A is not equal than last pin A, then this means pin A has changed. Yeah. And I have to compare. If pin B is the same like pin A. Yeah. Therefore, I make a boolean bool, yeah, turned clockwise. This I set to false. Turned counterclockwise is also false. And here I will turn clockwise. Yeah. This is the case if the pin A and pin B are different. This is at least what I said. Yeah. Digital read, and now I read pin B, and if this is not pin A, then it's turning clockwise, and if it is equal to pin A, then it's turning counterclockwise. Okay, then I can say last pin A equals pin A, store it for the next round. Okay. What I want to have is that I want to have a static integer, yeah, a value. It should be 0 at the beginning, and if I'm turning, if turned clockwise, I will increase the value. If I turn counterclockwise, I will decrease the value. Okay. I think this should be it, because it's false. Every time it's false, I'm not changing the value. Every time it can only get through in here. Yeah, it can only get through in here. So I'm setting either clockwise or counterclockwise when pin A is changed, and then I increase or decrease the value. Okay, and serial print, I will print value, serial print line value. Okay. I think this should be already pretty good. So let's check, let's verify if I have somewhere typo or something like this, which never happens, of course. If you have seen the other videos, you know what's happening. Okay, download, upload. Damn it. Value 0. Okay, now I'm turning -2, -4, -6. Okay, because but Now I'm turning clockwise. It's going down. Okay, so this means A and B are not A and B. I have them wrong. Yeah? So what I simply can do is I turn here the assignments, and then it should be okay. Value 0, turn it clockwise. Going up. Turn it counterclockwise. Going down. Working. Good. What I do not like is that there is all this value is printed so many times. Okay. I will just write it here. Every time I change the value. Turned clockwise. And here right, turned counterclockwise. This should now help to reduce the output. Reading from encoder, look, not much. Clockwise. You see, there are sometimes counterclockwise. Only if I turn with a decent speed, it's correct. Counterclockwise, I can turn. Also, there are also some clockwise in between. Yeah, but basically it is working. Yeah, I can adjust it up or down. Sometimes something is disturbing me. Sometimes there are wrong readings. Okay. What I do with the button? I will simply set it to 0. So we'll make it here. If digital read button pin not digital read, of course, yeah, because it's pulling up, yeah. And then I set the value to 0, and I will tell myself reset. Reset. Upload. Reading from encoder. 1, 2, 3, 4. Yeah, it's going up. Nice. Press the button. Reset. Ooh, yeah. As long as I press on the button, I get the reset. It's clear. And now go down. Also working. Go up. Okay, that's nice. Okay. It's working. 2 things. Yeah. One thing you can solve yourself. That's your task. You can solve yourself. If you press the button, you see it's just resetting all the time. I just want to reset it one time. Yeah, not all the time as long as I press the button. I want to have it only the first time I press the button, that this reset is done once. Okay. Please try this. This is how it should look like. If you turn now clockwise or counterclockwise to some value and then press the button, it should only say one time reset. Yeah? Then I release the button and then I can go further from here. Press the button only one time, not all the time. Okay. this is the task. Try to fulfill it. And the other issue we're seeing, if I turn further, yeah, you see sometimes there's not only turned turned clockwise, it's also sometimes turned counterclockwise and even counting down. So it's 86, 87, 86, 87. Why is that? This is because sometimes you do get it a little bit too late. Yeah. Let's have again a look on our sheet here. Yeah. The thing is, I need a little time to watch, yeah, for my program. So I maybe watch here, I watch here, I watch here, I watch here, because this is my cycle time of my program. Okay, and this means if I have watched here and then the next time I watch here, yeah, even if I'm coming this direction, yeah, because I have not managed, my cycle time is longer than this, yeah, because I have not managed to look in this window, time window, I am looking here, yeah, suddenly I get a counterclockwise because now they are the equals. Okay, this is a timing issue which we see. Timing issue. Other way around also. Why is the other way around not that sensitive? Because those two waves, those two rectangle forms, they are shifted a little bit to each other. One time window is shorter than the other time window. This is why when I'm turning clockwise, I get it very often. If I'm turning counterclockwise, it is comparably stable. Yeah. This is the reason for this. The reason for this is exactly our cycle. If I would remove now all of my serial outputs, then it would get better, because a serial output really takes time, and then we are for sure very fast enough. Yeah. However, then I do not see what is going on. Okay, that's the issue here. Yeah. And how to overcome this issue, we will see in our next video, because in next video we are trying to only distinguish between clockwise and counterclockwise with a help of a so-called interrupt. What this interrupt is, we will see next time. For this time, thank you very much for listening. Goodbye.